Okay, so the first question is about how the shape of the distribution relates to the mean and the median. So the facts that you have to remember is if the mean is less than the median, the graph is left skewed. If the mean is equal to the median, the graph is right skewed. Oh, I'm sorry, is symmetric. And if the mean is greater than the median, it's right skewed. Now, the next thing, so when we read this question, it says, if a distribution is skewed to the left, which of the following must be true? So it's going to be the mean is less than the median, and which choice is that? The mean must be less than the median, choice A. So IQ scores are normally distributed with a mean of 100 and a standard deviation of 15. Only about 32% of people have scores outside the range. So to me, that means that 68% are between what range? So I'm going to do normal CDF to each of these things and see which one gives me 68%. So if I do normal CDF, the lower bound is 85, the upper bound is 115, the mean is 100, and the standard deviation is 15. What percent do we get there? So 85, 115, 100, and 15, and I get 68% of the data is between 85 and 115 approximately. So that means 32% is outside of it. If you did 70 to 130, even though we already know the answer is A, if you do 70 to 130, 70 to 130 with the mean of 100 and the standard deviation of 15, you end up getting 95%. So this, you can kind of tell that, the answer is going to be 68%. 68 is between 85 and 115, so 32% is outside the range. Use the information to determine what percent of people have IQ scores over 110. What percent? That means it's a normal CDF problem. That's going to be normal CDF, 110, 1E99. The mean is 100, and the standard deviation is 15. It's not a sampling distribution problem. We just want to know the percentage that will have scores like that. And when we do it, 110, 1E99, and we have about 25% is what the answer is going to come out to be. All right, run times are approximately normal, so pay attention to the words with the problem. Past records indicate the probability it takes a child at school to run 100 meters is 16.12 seconds with a standard deviation of 1.6 seconds. What percentage of students have run times less than 15 seconds? So that's going to be a normal CDF. Negative 1E99, 15. The mean is 16.12, and the standard deviation is 1.6. And we're going to normal CDF that. Negative 1E99. Go ahead, type it all in. 15, 16.12, and then 1.6. And it comes out to be about 24%. You work for an ad agency that's preparing a new television commercial to appeal to women, and you've been asked to design an experiment. And then it says each subject will be shown one of 3 versions and then asked her attitude about the product. You should use A, completely randomized, B, categorical variable, a block design, a stratified design, a multi-stage design. Well, if we're talking about experiments, it would have to be a completely randomized design. Some of those things don't even exist really. The weights and heights were measured in pounds and inches respectively. A regression performed using weight to predict the height with the following results. Okay, the regression equation is, remember, next to the word constant is the y-intercept. And next, the word under that is the x variable. So it's going to be plus 0.20001. And then this is going to be weight. So, and we are predicting height. So our height would be be a height hat. So it would be, let's see, this one. See. Which of the following is correct? And we're using that above problem. So they're really talking about the interpretation of the slope. So the interpretation of the slope is, our sentence was, as the x increases by 1. So as the weight increases by 1 pound, so if the weight increases by 1 pound, the height is expected to increase by 2.001. It shouldn't be pounds though, but it should be inches. But anyway, so that if the weight increases by 1 pound, the height is expected to increase by 2.001. It shouldn't, I have a typo in there. If the weight increases by 32.7, no, so this one should say inches, but the answer is supposed to be C, but you know how I can't type or anything. But a marketing survey compiled data on cell phones in households. Then if these are the probabilities of having certain number of cell phones in a household. What is the probability that a randomly selected household has at least 4 or cell phones? At least 4 means the probability of 4 or the probability of 5. Well, the probability of 4 is 0.05 and the probability of 5 is 0.03. So if we add it, we get 0.08. A business evaluates a proposed venture as follows. So we're making a probability distribution here. The outcomes are, you can make $10,000 with a probability of 7/20. To make a profit of $5,000, that would be 9/20. To break even, that means you make nothing. That would be 1/20. And to lose $5,000, it would be 3/20. So if we do this probability distribution, do this probability to find the expected value, expected means mean. So stat edit, type in the outcomes in L1. So 10,000, 5,000, 0, and -5,000. And then the outcomes in L2, 7/20, 9/20, 1/20, and 3/20. And then stat calc 1 variable statistics, link L1 with frequency list L2, and you will get $5,000 is the expected profit. Jen's commute to work requires she take the blue subline, then transfer to the red line. The length of the trip on the blue has a mean of 14 with a standard deviation of 3. The red has a mean of 10 minutes with a standard deviation of 1. And the wait time in between the two has a mean of 7 and a standard deviation of 8. Assume these times are independent random variables. What are the mean and the standard deviation of her entire commute? Well, the mean is going to just be the sum of all these different mean times. So it's going to be 14 plus 10 plus 7. which is going to come out to be 24 plus 7 is 31 minutes. Okay, so we can instantly rule out some of these answers. Then it says they're independent random variables. So when you combine distributions, the standard deviation is the square root of the sum of the variances. So it's going to be 3 squared plus 1 squared plus 8 squared. And if we do that with the calculator, the square root of 3 squared plus 1 squared plus 8 squared, we end up getting 8.6. So the answer comes out to be C. Here's a cumulative relative frequency graph for number 11. And we are asked to find the median age. The median age is the 50th percentile right here. So we read across, and the age is 20. A least squares regression line for predicting the weights of basketball players on the basis of height produced a residual plot with a completely random plot. What does the residual plot tell you about the linear model? So remember, a residual plot needs to look random to suggest that a linear model is appropriate. A random pattern shows that a linear model is appropriate. Okay, so this problem is the mean number of hours worked by 30 males was 8, and the mean number of hours for 20 females was 6. So you're going to do 3 times 8, or 30 times 8, plus 20 times 6, and divide by the 50 people who were doing the work. And that will give you the weighted mean for that problem. So 30 times 8 plus 20 times 6, and then you divide it by 50, and you end up with 7.2. Okay, so we had talked about outliers a little bit. So what would happen if this point in the upper right was removed from the data set? What will happen to the slope, and what would happen to the R? Well, nothing really is going to happen. That point is sort of like on par for being on the line. So removing it really does, even though it's far away from everything, doesn't really change what the slope would be, and it doesn't change what the R will be. So both will remain the same. Double blinding in an experiment is important. So the evaluators don't know what treatment the participants are in. Well, that's true. The participants don't know which treatment group they're in. That's true too. They don't know. And this is a control method to prevent the placebo effect or bias. Also true. The answer is B. In an AP Stats class, 57% of the students eat breakfast in the morning, 60% floss their teeth, 40% do both. What is the probability that a student from this class eats breakfast but does not floss their teeth? Okay, well, this could probably be shown with the Venn diagram. We have breakfast and we have flossing. We're going to call this B for breakfast, this F for flossing. And both, 40% do it. Okay, so 40% do both. The breakfast circle has to total 57%. So 40 is in the middle. That means 17% is going to be over here. So it's not really to scale, and then 60% of students floss their teeth. Well, if 40% is in the middle, then that means 20% is in here. So if the question is, what is the probability that the student eats breakfast but doesn't floss their teeth? Well, the part of the circle that eats breakfast and doesn't floss their teeth is the outside section. What is the probability that a student eats breakfast given he flosses his teeth? Well, you have a formula for given. It's on your green sheets. It's the probability of A given B is equal to the probability of A and B over the probability of B. Okay, so the probability that a student, what is the probability that a student eats breakfast given he flosses his teeth? So the probability that a student does both is 0.40 given he flosses his teeth. So that's going to be, and it said 60%, I think, did both. Is that right? Yeah. So 0.40 over 0.60, if you actually divide it out, is going to be about 67%. According to the National Telecommunication and Information Administration, 70.5% of U.S. households had internet access in 2021. What is the probability that 4 randomly selected households all had internet access in 2021? So we have the number of trials and we have a probability of success, and we want to know the probability of all. So that's binomial. So the problem is going to be binomial PDF, because it's that's 4 out of 4. It's going to be 4, 0.705, 4. Okay, so binomial PDF 4.705 and 4. And you get about 25%, 24.7 actually, but that's close enough. Which of these has a binomial model? Binomial, remember, there's some characteristics. There's 2 options, success or failure. 2, the trials are repeated and independent, and the probability remains the same for each trial. So the number of people in a class of 25 who have taken statistics, so we would have a number of trials right there. So they either took statistics or they didn't. That's sounding pretty good. The number of people until we find someone, that's geometric, so it's not B. Just the number of people who drink soda in a day, that's a count. And the number of people until we find 2 who've taken statistics. Well, the answer is going to be A. The number of aces in a 5-card poker hand. Okay, that's all right. Sometimes some marathons allow runners to split a marathon with each person running half. Alice and Sharon decide to split a marathon. Alice's average is 90 with a standard deviation of 4. Sharon's is 94 with a standard deviation of 3. Times are independent. The expected time would be 90 plus 94, 184. What is the standard deviation of their total time? So you're putting these together. And so they're independent variables. And so it's going to be 4 squared plus 3 squared. And the square root of 4 squared plus 3 squared comes out to be 5. The principles of experimental design, randomization, replication, control, and comparison. So know what those are. The speeds of cars going through the Easy Pass have a normal distribution with a mean of 6 miles per hour, standard deviation of half mile an hour. What speed is at the 30th percentile? What speed is at the 30th percentile? So we are given a percentile. When you are given a percentile, that is inverse norm. So it's going to be 0.30. The mean is 6 and the standard deviation is 0.5. So inverse norm, the mean is 30 when it's 30th percentile, 6 and 0.5. and it comes out to be 5.7, 5.73. If the data is skewed, which of the following are the preferred measure of center and spread? If data is skewed or has outliers, you have to use median and IQR because the median is resistant. Okay, the median is in the middle, so it's not going to be affected by those extreme values. Suppose the average on a national test is 20 with a standard deviation of 5. If each score is increased by 5, what are the new mean and standard deviation? Well, these are SIR questions. So if you add, the new mean would be 25. But the standard deviation would not be affected by the addition, so the answer would be B. Suppose the average score on a national test is 20, standard deviation 5. If each score is increased by 50%, what are the new mean and standard deviation? So when you have this increased by a percentage, you're multiplying by a number. So you're going to do 20 times 1.5, and you're going to also multiply the 5 times 1.5. So you're going to end up with 30 and 7.5. Okay, what type of data is, remember we have two types of data, categorical and quantitative. Categorical is a quantity, is a category. Quantitative is a number that makes sense to add, subtract, multiply, or divide. Number of siblings, that's quantitative. Eye color, that's a category. Gender is a category. Number 29, rats with cancer are divided into two groups. One received 5 milligrams of a medicine, the other received 10. After 2 years, cancer spread is measured. This is an experiment. The rats were given treatments. A poll is conducted in which 500 people were asked who they planned to vote for. No treatment, just an observational study, just observing what the people say will happen. To estimate the percent of defects in a recent manufacturing batch, a quality control manager selects every 8th chip that comes off the assembly line. That is systematic. So you do need to know cluster is groups, and then you use one or more of the groups and test everybody within the groups. Convenience, bad. Simple random sample, random number generator, names in a hat. Stratified is groups, and then a little bit from each group. To determine his DSL internet speed, Sean divides his day into 4 parts: morning, midday, evening, and night. And then he measures his connection speed at 5 randomly selected times from each part of the day. So he did groups and then did 5 times in each part of the day. That's stratified. To determine IQ scores of 9th graders, a school psychologist gets a list of high school students. She randomly selects 2 of the high schools and then tests all of the 9th graders at those schools. So she groups them by high school. She uses 2 high schools and then tests everybody in that group. Identify the type of bias present. An IRS officer, that's Internal Revenue, they do taxes. IRS asks people if they've ever cheated on their taxes. That would be interviewer bias. A survey is sent to 1,000 business owners and only 50 surveys are returned. It doesn't even matter what was asked. There's a huge non-response bias there. Okay, and then in the next one, now we're starting the FRQ part. A psychologist has 100 volunteers, 50 males and females. She believes boys and girls respond differently to instruction. There are 2 instruction methods, A and B. Design an experiment that will eliminate variability due to gender. Be sure to discuss random assignment. Okay, so if I start with my 100 volunteers, since she believes the gender is going to affect the outcome, we're going to block by gender. And we're going to put the 50 males together, 50 females together. And then we are going to randomly assign 25 to each treatment. So this part will be randomly assigned. 25 males to A, 25 males to treatment, to instruction B, 25 females to A, 25 females to B, close it up, compare results, compare, and then we're going to overall compare test results or whatever they're doing. Now it says to discuss random assignment. Assign each male and female a number from 1 to 50. Use the random integer generator. I'm not going to write the rest of it because I don't have room. Use the random integer generator with no repeats to select 25 different numbers between 1 and 50. That group will receive treatment or instruction A, and the remaining 25 will receive instruction B. So that would be how I would do it. If you use the random integer table, you would I would probably go from 0, 0 to 49, and the first, the numbers from 0, 0 to 24 would go into group instruction A. The others would go in group B. And you have to mention, if you use the table, what happens with repeats and what happens with numbers over your given numbers from 0 to 49. So throw those out. Number 37, the mean hemoglobin for cats is 10.1. Standard deviation is 1.8. So find the z-score for Blackie, whose hemoglobin is 7.8, and interpret this value. So his z-score is going to be 7.8 minus 10.1 over 1.8. Okay, 7.8. And remember, z-scores are always given to 2 decimal places and then divided by 1.8. And so you get negative 1.28. That's your z-score, negative 1.28. So this means Blackie's hemoglobin this pen is really freaking out. This is supposed to be an H. Blackie's hemoglobin is 1.28 standard deviations below the mean. That's all the interpretation is. What is the hemoglobin level for a cat whose z-score is 1.44? So the formula would be the z-score is 1.44. We don't know the cat's hemoglobin level. This mean is still 10.1, and the standard deviation is still 1.8. If we cross multiply this, 1.44 times 1.8, and then we add 10.1, we end up getting x is equal to 12.692. Okay. The snowpack of the Summit Wolf Creek Pass, Colorado, is normally distributed, mean 78 inches, standard deviation 10.4 inches. A year is selected at random. What is the probability that the snowpack is less than 60? So this is just one random year, normal CDF. Lower bound is negative 1E99. Upper bound is 60. the mean is 78 and the standard deviation is 10 point something, and I just flew around here. 10.4. Okay, so for A, normal CDF, giving you time to type it in. So the answer comes out to be, and I'm still typing because I'm having a problem doing two things at once. Comes out to be 0.0417. Okay, what's the probability that it's more than 85 inches? That's going to be a normal CDF, 85, 1E99. The mean is 78, standard deviation 10.4. That's going to be 0.2504. What is the 99th percentile for snowpack? That's going to be inverse norm, 0.99. The mean is 78, and the standard deviation is 10.4. And when you inverse norm that, you end up getting 102.19. And then what weight represents the highest 5% of snowpack? So the highest 5% is to the right. Remember, when you do inverse norm on the calculator, it's always to the left. So it's going to be inverse norm, 0.05, then, so 0.95, and then 78 and 10.4. And that's going to be 95 inches, 95.106. This next equation, this is, you have to do with your calculator, find the line of best fit and the correlation coefficient, coefficient of determination, blah, 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 blah. Okay, so first thing you have to do is type the information into stat edit. Okay, so in L1, I've typed in those, and now I have to type in L2, so you get a minute to do it too. Okay. And when we do stat calc 8 for one variable statistics, we end up getting y hat equals, and then we get negative 81.32 plus 3.420x. Our R number comes out to be 0.999511, and the coefficient of determination is the R squared number, which is 0.9046. Okay, then it asks us to interpret R squared in the context of the problem. So this is about 90%, 90.4% of the variation in whatever the Y is. The Y was yards, is explained by the linear regression of yards and club head speed. Okay, interpret the slope in the context of the problem. Well, the slope was 3.420. So as x increases by 1, as club speed increases by 1 mile per hour, That's an H. The distance is expected to increase it's increased because the slope is positive by 3.420 yards. The y-intercept in this problem is 0, negative 81.32, and interpret it in the context of the problem. Well, that one, again, doesn't make sense that your yards would be negative 81. So when club head speed is 0, yards traveled is negative 81.32 yards. This is extrapolation. Remember, 0, if you look at the original data, 0 is not an x, one of the x coordinates. We can only plug in values from 99 to 105 into this equation. Okay, so now we have this table with medals from the 2004 Olympics. And the question is, if a medal is selected from the top 8 countries, find the probability. So we're finding the probability that it's from China. So China's total is 63 over 457. So 63 over 457. What's the probability of it being a gold medal? Well, that's going to be 162 over 457. The probability that it's China and it's a gold medal, China and gold overlaps right here. So that's going to be 32 over 457. This is when it might help you to look at your green sheets. You have a formula for the probability of A or B, which is going to be the probability of China plus the probability of gold minus the probability of China and gold. Okay, so the probability of China we know is 63 over 457. The probability of gold is 162 over 457. And China and gold is 32. So it's going to be 193 over 457. China or gold given China. So this is going to be the probability of, well, you can use your formulas, or since it's a table, which is much nicer, you can just look under a specific row or column. So gold given China. So you can only look at the China row. Gold given China is going to be 32 over 63. Now, for the formula for China given gold, so that's going to be the other way around. It's going to be China given, you're only looking in the gold column. China given gold is going to be 32 over 162. Or China and gold independent. So to test that, is the probability of China equal to the probability of China given gold? Well, the probability of China was 63 over 457. The probability of China given gold is 32 over 162. 63 over 457 is about 0.13785. 32 over 162 is 0.1975 something. Are they the same? The answer is no, because they are not the same. They are not independent. The second one, are China and gold mutually exclusive? If something is mutually exclusive, then the probability of A and B equals 0. Well, the probability of China and gold is equal to 32 over 457, not equal to 0, so not mutually exclusive. Okay. About 5% of rhubarb plants die before producing any rhubarb. Suppose you buy a bundle of 10 plants. Find the probability that exactly one plant dies. Well, you know the number of trials. You have the probability of success. Exactly one. So this is going to be a binomial PDF. So it's going to be 10 plants, 0.05, exactly one plant dies. So binomial PDF 10 comma 0.05. Whoops. And 1 gives us 0.315. Find the probability that at most one is less than or equal to 1. So this is going to be binomial CDF 10 comma 0.05 comma 1. So this one's going to be binomial CDF 10 0.05 1. And you end up with 0.914. Find the probability that more than one plant dies. More than one, more than is 1 minus binomial CDF. And more than, with the hard number is to figure out what goes there. We know it's 10. We know our probability is 0.05. More than one means 2, 3, 4, 5, 6, 7, 8, 9, 10. So we're not interested in 1 or 0. So we're doing 1 minus binomial CDF 10.05 and 1. And you're going to get 0.08 something, 0.086. What is the expected number of plants that will die? Well, the formula for mean for binomial is n times p. So 10 times 0.05 is going to give you 0.5. The formula for standard deviation is the square root of n times p times q. So it's going to be the square root of 10 times 0.05 times 0.95. And you end up getting 0.6892. Okay, 42. When an opinion poll calls a phone number, only 20% of calls reach a person. You make calls. Find the probability that you reach a person on the third call. So that means you're going to repeat until you get a person. So this is geometric. So this is going to be geometric geometric PDF. The probability is 0.2, and on the third call, that's the X value, and you're going to get 0.128. Before the third call means less than 3, means in the second call or the first call. So this is going to be geometric CDF 0.22. Before the third means in the second call or the first call. So you're not interested in 3 or more. So binomial or geometric, I keep saying binomial, but it's geometric CDF 0.22, 0.36. Find the probability that you reach a person after, which means after the third call, greater than 3, means 4, 5, 6, 7. So the probability is going to be 1 minus geometric CDF 0.2 after the third, fourth, fifth, sixth. So we're taking off 3 down. So 1 minus geometric CDF 0.2 and 3, 0.512. What's the standard deviation? The formula for standard deviation for geometric is 1 over p, which is, this is going to be 1 over 0.2, which is 5, and the square root of q over p squared. So that's going to be the square root of 0.95 over 90, where did I get 0.95? 80. Q is going to be, if P is 0.2, Q is 80 over 20 squared. So the square root of 0.8 divided by 0.2 squared. You get 4.47. Okay, we're getting close. According to veterinary records, the average cost to care for a dog is $250. Standard deviation is 45. Veterinary costs follow a normal distribution, and assume veterinary costs for dogs are independent random variables. What is the average cost of owning 2 dogs? Well, to care for 1 dog is $250. So 2 dogs would be $250 plus $250, which would be $500. What is the standard deviation of having 2 dogs? Well, since they are independent variables, we would know that it would be 45 squared plus 45 squared. The square root of 45 squared plus 45 squared comes out to be about 63.64. 6496. Okay, what is the probability that you would spend more than $600 per year if you had 2 dogs? Well, we know that veterinary costs follow a normal distribution. More than 600 is going to be normal CDF. 600, 1E99. The mean is 500, and the standard deviation is the square root of 45 squared plus 45 squared. And we get 0.05, 0581. Okay, here is a probability model here for this question. And that we're kind of at the end here, but probability model, what do we know a probability model has to total? We have to, it has to total 1. So we're going to have to figure out what that missing number is. So if we add the 68, the 5, the 7, the 8, the 4, the 1, and the 2, we get 95. So this probability of 4 is 0.05. Okay, so what is the probability of 4? That's going to be 0.05. And then we have to find the expected number. So stat edit, we're going to type this probability distribution in, and then find expected number is the mean. So I'm typing in those probabilities. one variable statistics L1, L2, you end up with 1.03 for the mean, and the standard deviation comes out to be 1.769. Use the stem and leaf below. This is the prices of 40-ounce insulated tumblers. They go from $18 all the way up to $62. Find the mean. So this entire thing can be done on one variable statistics. The only thing you're going to have to know for sure is this formula. The formula for IQR is Q3 minus Q1. You also need to know the outlier formulas, which would be Q1 minus 1.5 times the IQR. And this would be Q3 plus 1.5 times the IQR. And then discussing the histogram, that is cussing. Okay, so I'm going to go ahead and spend a minute typing this stem and leaf plot into the calculator so I can do all of this on the calculator. Okay, so when you do your one variable statistics, and remember the rounding rule is to give one decimal place more than the original data set gave. All right, so to find the mean is going to be 38.46, which is going to round off to 38.5. The median, if we scroll down on the calculator screen, comes out to be 39. The standard deviation, that is the SX number on the calculation, because we're talking about a sample, 12.1. Now, remember when you're doing variance is standard deviation squared. You do multiple decimal places. You don't just say 12.1 squared. So you can do that on the calculator with VARs, statistics, which is number 5, and then number 3, which is SX, and then hit squared, and you get 146.6. The range is the largest piece of data minus the smallest. So it's going to be 62 minus 18, and 62 minus 18, it comes out to be 44. The Q1 number from the calculator is, when we scroll down, Q1 is 29 and Q3 is 47. The maximum is 62. The IQR is Q3, 47, minus Q1, which is 29, and that comes out to be 18. The 5-number summary, remember, goes in set braces. It's the 5 bottom numbers on the bottom of the Stat Calc one variable statistics screen. It is 18, 29, 39, 47, and 62. The formula for finding the outliers, it's going to be Q1 minus 1.5 times 18. And this outlier formula for Q3 is going to be 47 plus 1.5 times 18. 29 minus 1.5 times 18 comes out to be 2. And 47 plus 1.5 times 18 comes out to be 74. So we have no outliers in this data set because we have no tumblers that were less than $2, and we have no tumblers that were more than $74. Discuss the histogram. Remember, cussing is context plus you mentioned the center, the unusual, the shape, and the spread. You can even look at the histogram if you want on your calculator, if that helps you get into the into doing it better. You certainly can look at it. It's not necessary probably because you have all the other information, but anyway, and if you hit Zoom 9, that will let you see it. So I would the histogram of tumbler prices, remember context, is approximately normal, or is approximately symmetric. How about that? Because the mean, which was what was the mean? 38.5 is almost equal to the median, which was 39. So I've done the shape. The center, I'm just going to always discuss median and IQR. The median is 39. And the IQR is 18. There is nothing unusual about the histogram. That would do it. The end.